there, Alejandro. Welcome back for day 264 of me doing Daily LeetCode challenge at least 1 year's worth of great contributions here on GitHub. So today's for us for April 6, 2025. And without further ado, let's get straight into it. Okay, today we get LeetCode medium problem 368, largest divisible subset. Okay, given a set of distinct positive integers nums, return the largest subset answer such that every pair. Okay, I see largest maximization problem. Subset, this is probably going to be a DP problem. Okay, distinct positive integers num return the largest subset answer such that every pair answer via answer of j of elements in this subset satisfies this. Answer modulo, or 0 or... Oh, I see, okay. If there are multiple solutions, return any of them. Yeah, okay, this is just going to be classic TP. So here we can just do self.nums is equal to nums. This is good because I have, my friends just left me here so that I can do the LeetCode. They're going to play board games for an hour. So if I can solve this fast, I'm actually going to get to join them, which is pretty darn cool. So let's just do this. Here we'll say nums is equal to self.nums. N is equal to length of nums. If I is going to equal to length of num, to n actually. Then what will we say? Then the largest subset answer. What is the value of a subset answer? Oh no, they want me to return the subset itself. What's the constraints? It's 1,000. Interesting. I guess with DP it's like I can keep track of, like, you know, res. Yeah, that's annoying. Here we'll do. Oh, and all the numbers are distinct, so we can just, yeah. Here we'll say, which is good, return self.dp from index 0 and then an empty array, right? If I is greater equal to res, then return res, right? And here we'll say, how do I want to do this? All right, yeah. Rest is equal to dp of I plus 1. Whoa. Oh, I should say I can add index I if the previous one. Yeah. Here we'll say num is equal to num of I. Case 1 can add num at index I only if possible. Case 2, don't add num at index I. Right, so here case 1 will be equal to yeah, we're going to do a DP part. Darn. Maybe there's a greedy way of selling. No. DP just makes a lot of sense here. I just got to figure out how to do it, right? Or modulo yeah, this is gonna be tricky. This is gonna be tricky. Maybe I should do, yeah. This is 1,000, right? So we can't afford an n squared solution. So maybe we should do this based off an I and a j, right? Where this is like the previous chosen index. Yeah, I think so. Prev index, prev chosen index. This should be none. Yeah. But then how do we build a solution? Yeah, it's kind of annoying because then we got to build a solution, right? They don't want the length, they want the array itself, which is really annoying. That's what makes it annoying. DP is good when you want to return, like, oh, the length of the largest possible valid array. Right, because an easy way is to backtrack. We could do a prev val. What's is something modulo 1? No. Yeah. To make this prev val, and there's only up to n unique values. We could make it 1, right? Because if I take any number, Python 3, 0 modulo 1, 1 modulo 1, 2 modulo 1, random.rendint, that modulo 1, import random. Yeah, so maybe I could just do that. So that way that's always going to be satisfied. X modulo 1 equals 0 for any x. There we go, just so that we match the constraints here. Maybe I can have these things return the arrays themselves. Will get a little tricky, but I guess we could do that. It's just going to be pushing it, right? Because this is already n squared work. Adding arrays inside will not be fun. Right, it's like I need to store somewhere where there's a prev chain, right? Like the way that I do my caching in my self.memo. Yeah, maybe I should keep track of a prev index. And inside of a self. So yeah, maybe we should have a unique memoization table. This we should do prev index. Return self.dp of 0, none. I gotta think about it. Like maybe in my memo table, out of my 2 options, I return like, okay, like, the length of the longest one, and also like the index of the one I chose, right? Something like that. If I come up prev index in self.memo, of I, comma prev index. So here we gotta be careful, right? 0, an empty array, something like that. Or next index is equal to none. Maybe I do I every single time. Yeah, if prev index is none, or prev modulo equal to nums of prev index modulo 0, or num modulo prev equals 0. Rest is equal to dp I plus 1 and I. Prev index remains the same, right? If case 1 length is greater than case 2 length, self.memo of I, comma prev index is equal to case 1 length plus or equal to 1, since including index I. Is equal to, here we'll do say case 1 length, and then it's just we chose index I. Maybe I do an assert that this is I. Of index index. Return set.memo of I, rev index. String I equals rev index equals case 1 length case 1 index equals case 2 length case 2 index equals not bad. Yeah. This length. Interesting. A string set.memo equals so 0 none or 0 none. Zero none maps to 1 and 0. Sweet. So it should have a value of 2, yeah, in total. Oh, none of these have a 2. No, because we added 1 here. I think there's 0 left. It could also just be greedy, but I doubt it, right? Oh, we could also definitely do DP. Ah, wait, I'm dumb. We can definitely do DP where we just try a solution that starts at every single index I, right? Because if we do that, then if we force it to start at an xi, that's like, then you might as well start adding stuff, right? Yeah, we could definitely do something like that. So how the hell is this getting that? Oh, what the heck? This should be a case 2. One, 1, 1, 1. Oh, 2 and 0. That's very neat. Yeah, case 1 index. Yeah, I'm definitely getting to something close here. Yeah, I'm obviously going to be able to get the length, right? But that's not just what we care about. I do like the idea of trying this from every single index I, right? That would definitely be nice and working. I could definitely try to make this work, but that idea does sound a bit easier to implement. This I could probably just try to work around. Right, the only thing is like, I know you pick 0 first, but that's like, what did you pick next? Yeah, this is just not gonna work. I can definitely get the lengths. One thing I could do. Ooh, one thing I could definitely do is essentially use DP to find the longest lengths, right? And then it's like find out which index I there's the largest value on. Start from that one. Add it, right? And then it's like keep going until you get to the one that's 4, add that one, get to the next that's 3, add that one. Yeah, we could definitely do something like that. Yeah, I have many ideas. Let's try the one I'm thinking of right now. If anything, right? Here I'm just going to, yeah, let's just, everything's gonna get commented. UT. Right, there we go. Def dp self index I. We'll still have a self.nums is equal to nums. And here we'll still do self.nums is equal to self.nums. N is equal to length of nums. Y greater equal to n. Turn 0. Yeah, this will be based completely on getting lengths, right? Case 1, include nums of I. Case 2, don't include nums of I. Num is equal to nums of I. Here we'll say case 1 is equal to well, oh, I'm gonna have to satisfy this for every single pair, right? Yikes. I'm gonna pray that you can just do a prev val. Right, if everything is like divisible, hopefully adding a number. I'm gonna take a risk and just assume that that's a thing, and if it's not, then it's not. Right. That'll make it less prone to bugs. We have I plus 1, I plus 1, num. Case 2 is equal to 1 plus Preval. Or preval modulo num equals 0. Float of turn max of case 1 from the case 2. Let's just do something like this for now. U0 is 2, UT, is this a 4? Yeah, this is beautiful. Okay. Yeah, so I'm just gonna pray that, like, you know, holding on to the last number is enough, because populating this will be O of n squared, and that will make this problem solvable, right? Now what we want to do is, like, okay, equal max of I, comma 1 range n of nums. Those are the pens. Nums of I. And then here just return res, right? Something like this. Comma 1. Yeah, you know what? I'm just gonna do this. It's equal to 1. Okay, it's accepted for these two cases. Now let's see, is it accepted in the general case? Because if so, then that means that this thing is valid, which would be quite nice. Nope. Oh, rip. That is a big fat rip. Well, that's interesting. Yeah, they're gonna give me some annoying things, eh? Printf string. Delta dp of I. Yeah. Yeah, so this is not gonna be good enough. What is it? What? Why? Oh, because the next possible solution is this 3. Yeah. That's actually an easy fix. Here's how we fix this. That's actually an easy fix. We just remember something here. Self.memo is equal to this. We will say if I come up with val in self.memo, in self.memo of I come up with val returns next thing. index I was used. Bool. Right, something like this. Really now. What? Okay, so these are accepted. Now, is this accepted in the general case? Is my question. Either we're going to get a wrong answer, output limit exceeded, or a pass. Wrong answer, yeah. Okay. So the expected was indeed that. So here I said 3 is just true. Expected is 4823. Yeah, 4 was used. 1 is 2, which is good. And a false. Maybe here we can solve this with a little bit of this. Okay. Yeah, but eventually we're going to start failing stuff, right? If I remove this caves 5 class. Yeah, it's going to be one of those. Yeah, so just prev val is not going to be enough, right? We're going to have to think about what it means to actually be divisible by something. Oh, maybe I take the product of everything? Right? Maybe I do product. That way it's like I have a product of all the numbers so I can see if it's divisible. I mean, we can try. Yeah, I'm not really sure if this is gonna work. Yeah. Shouldn't this encourage bigger solutions? Right, that would have made a lot of sense to me. I definitely like the idea of trying every solution that starts at a fixed index I. I don't know. It's quite interesting, right? One of the two numbers, if x and y are divisible by each other. If x is divisible by z or z is divisible by x, doesn't necessarily mean it's divisible by y. Alright. If you have 2, 3, and 8, although that doesn't work. Yeah, 2, 6, and 8. 6 modulo 2 equals 0. But for 6, 8, and like, how are you gonna do this without going overboard? Well, what, I've never seen it like that. Well, there's no hints for this problem. 46% acceptance rate, that's pretty bad. Currently 1.3k people on it. It's annoying. Subset problems that are not intuitive with backtracking or DP are hard. Like this feels like it should be very DPable. I have to do this in n squared somehow. So it's like I can make DP, I can have one DDP that returns an array and then iterate over that array. So that would be O(n) work inside of the body of each DP. That's really the time complexity I'm allowed to work with here. But then I'm not allowed to do... No, I can do O(n) work in the body. That's the point, right? Okay. Okay, maybe we do something like that. Okay, here I'm just going to restart the problem. We'll do nums p of index I. Dot nums, n is equal to length of nums. If I is going to equal to n, then return just an empty array, right? Otherwise, rest is going to be equal to sub.dp of I plus 1 dot copy. We'll say num for num in this, right? We're going to do O(n) work inside this body. So we might as well get comfortable with it. Then we'll say num is equal to but I'm not doing DP, I'm doing greedy. Yeah, this is greedy. I can't do this. Yeah, this is just greedy. gosh. It's quite tricky, I'm not gonna lie, it's quite tricky. Both yesterday, even yesterday was tricky, like, I couldn't figure out a DP solution to a subset problem, and today feels the same. This is very bizarre. I hate that this is what they want to return. Even that is just... Yeah, best possible solution might be incompatible. It's just too much in time complexity. I can't do this in n squared. Darn, man, this is hard. Clearly it has to be an n squared solution, but this is tough. What the heck? Why am I stuck here? It's a subset problem. There's no hints. Do I have to somehow manipulate what it means to be divisible? Right? Either x is a multiple of y or y is a multiple of x. So do I always keep the biggest one, the smallest one? Product. Product would have made sense. You can't have 2 DDP and O of n work in the body, because it's an M-cube solution. That won't work. Literally, how do you do this problem? I'm actually kind of stuck. I'm generally stuck. I wish there was a hint for me to look at. Do I take a break and do this tonight? I'm stuck. Like with DP, like when you approach a subset problem without backtracking with DP, backtracking is off limits. We need an n-squared solution. I've become so. It's almost like you want to waste O of n more time, always verifying that you can add a number. Maybe that's exactly what I'd do. Let me go back to where I had the prevnum stuff. Come sign on like a no. But no, this enforces greediness. I hate this. No. Because you force it to start at an index I. I've become so numb. Yeah, so the solution for index I will always be dp of I plus 1 with the set of... Yeah. Become so numb, I can feel your tongue. So numb. I become so numb. Become so numb. For I wanna know oh yes, oh yes, oh yes. Could do a backtracking at the end, but yeah, there's just gonna be. I'm missing some trick, man. I've become certain. I don't want this to be like a, like kind of one of these impossible problems. Do we look at discussions? Nah. Yeah, I'm not gonna be able to join board game night with my friends anyways. Oh well. Oh well. It's LeetCode time. I do not get it. Like what topic is this? Am I just being fooled by DP or so on? Because like, yesterday like the XOR problem with like bitwise ordering for solutions so on. It was not DP. This is gonna be one of those where it's just like there's a trick and it's not DP. Okay, I'm gonna look at the. All right. We're gonna take a look at the discussions. This is me being a bit lazy today, so forgive me, please. But yeah, I'm just gonna try to do this so I can work out a little more after. Yeah, this is just cope. Usually I would probably try a little harder. It's just here I'm stuck. I've already spent about an hour. I kind of need something to push me forward. I usually would look at a hint, right? Because some of the discussions sometimes it's like you gotta be careful not to get spoiled the solution. But since there's no hints, I definitely don't want to just look at the editorial blatantly, so we'll do the next best thing. And look at the discussions right about now. Okay, careful with discussion 1. Example, okay. Okay, so this is a DP problem. Yeah, this is exactly what I mean. Do not give me the solution. Finding the clique maximal. No, am I dumb? If you turn this into a graph problem, yeah, you want to find the largest clique. Wait, but that's insane. Wait, that's actually kind of insane. Cliques over here? When there's up to 1,000 nums? Because clique, like that's exponential. That's not polynomial time. Yeah, okay. First of all, I'm gonna clarify. This is very obvious in terms of why summing clique is gonna be possible, right? If two indices I and j are, modulo gives you 0, put an edge from I to j, j to I, put an edge from that to 0, and you essentially want to see is there a clique of size k, or if either of these is true, just put an undirected edge, right? And then it's like, yeah, clique of size k means that those k nodes essentially are all valid. Yeah, NetworkX, I saw this in the Advent of Code playlist. People use this NetworkX library. Let me do something like this. Import NetworkX. NetworkX. Maybe here we'll do pip3 install NetworkX. Python 3 import NetworkX. What happened here? Huh? NetworkX. Bro. The heck? Bro. Okay, we'll let that run. Otherwise, what I can do here is just help network X, right? I should probably stop this. Okay. Import network X. Is that what it's called? What is it called? What is it called? Let me open these guys up. Where's the library, man? Yeah, I want maximal click, right? Yeah, I've seen people use NetworkX instead of the Advent of Code. I wrote my own, like, click solver, but that's just because, like, the max click was, like, 13 or something like that. I was like, it's doable. Well, because the graph was, like, really nicely set up. But, like, at that point, you might as well do backtracking. I don't get it. Is there just a DP way of solving click? What is this? Network X? What's the Network X module? Settings. What's the library called? Install. Okay, this is what it's called. Does oh no. Well, first of all, let me do pip3 install network X. Bro, maybe pip install, and then it won't complain. There we go. But so this is really just not something that LeetCode supports. That's a bummer. Yeah. If you think of this as a clique problem, like that's insane to be asked to solve this. This reduces the clique. Bro. How the heck am I gonna solve this in n squared time? Dude. Wow. I mean, wow. I mean, it's definitely going to be something related to the fact that there's this property, right? Like this, the fact that relationships are defined in this way makes me figure that this can probably be abused one way or another. Because if you cannot abuse that one way or another, then this problem is clique. This is an exponential time problem. So somehow you must use the modulo operator to your advantage to make this polynomial time algorithm, and specifically n squared. Some way of aggregating all the values together. Product doesn't do it. Something else probably does it. Yeah, let's see what this guy has to say. The problem reminded me of the issue of finding the clique maximal. Yep. Yeah. Ashburn said, yeah. This is a cool comment. First solve longest increasing subsequence. Yeah, well that's easy. One best DP problems out there. Then this is hard. I wrote the cursor. Okay. Don't post solutions. Fun fact. Yeah, the difficulty levels. Things to note. Why must we? Okay. Well, that. Okay, well, first of all, sorting doesn't hurt if you're gonna have an n squared solution. That's something I always forget. Why would sorting be relevant here? Something about max and small numbers, eh? Something's divisible. 1 and 3 are divisible with each other. Do you just keep track of the maximum number? Like, instead of product, I would always do max. It doesn't make sense to me. There's gotta be some way to abuse these modulo operations. Do you keep track of the max one? Let me get back to a point where I had products. Alright, something like this. That's interesting. Max worked, eh? And now this guy's failing. So max doesn't work, min doesn't work. Product times num doesn't work. Wow, what? How annoying. Just how annoying. True, true, true. Ugh. How do you aggregate? Yeah, you're gonna need to aggregate somehow. Like, do you keep track of the remainder? Right, product modulo num or num modulo product? Like some crazy thing like this? I don't know. Yeah, this weirds me out. Okay. Alright, I'm just gonna read what this guy says until I get to a point where I can do this. Usually for each number n, we want to find the largest divisible subset whose largest element is n. Largest divisible subset. Wait. For each number n, we want to find the largest divisible subset. Wait. I see, that's how he's gonna DP his way through it. Take the values of the n numbers and do something with that. I see. Yeah, that's a different direction than what I was thinking. I'm always used to DP on indices. Do it based on the values. I see. The largest possible subset from index I, where each number is divisible by an n. Does that work? Wait. Largest divisible subset whose largest element is n. Whose largest element is n. One element is bound to be largest. You might as well, yes. Whose largest element is n. N is bigger than you. You have 2 and 5, 2 and 10. Then yeah, the only way is if you divide into the n. But that doesn't necessarily, like if you have 2, 5, and 10, 5 and 2 are not modularable with each other. So this doesn't make sense. Okay. Sort the list first. Then all elements of S of n oh my god. That's insane. That's how he breaks down the problem? Holy crap. Yeah. Dang. Dang. But that doesn't make it n cubed? Why sort the list? Yeah. Yeah, store a pref set, yeah? Yeah. Yeah. I'm gonna upvote that comment. Wow. Wow. Selder. Thanks to you, man. That is cool. Oh, in 2021. Wow. Yeah, the prep stuff, like, this is exactly what you do in Dijkstra's. That's pretty cool. Damn. I did think of that at one point. It's the fact that anything that divides into m and m divides into n will have all of those divide into n. Again, yeah, you have to abuse something about the modulo operation. Otherwise, this problem is literally clique and exponential. That's the difference, yeah. So yeah, I just didn't know how to manipulate the modulo math. Darn, that's clever. That's pretty smart. And when I keep that comment open, yeah, damn. Wow. He says sort the list first. I mean, I might as well. Nums that sort. I don't get why, but a crucial operation. Oh, because that way you it's gonna be for the searching part, right? That way you limit things in terms of, instead of doing all O of n, you might as well just make it efficient. Yeah, okay, I get why they're sorting. Like for example, if everything's sorted, then you can just look at all the elements that are greater than you, or all the elements that are smaller than you, by just going through one of the two halves of the array, instead of looping through the entire set of nums every single time, right? It's just a little bit of efficiency, so that does make sense. Is equal to all numbers distinct. Touch. Right. Max num modulo num is equal to 0. And here we'll say this is a valid candidate. This is equal to, this will be all of those guys. Current num and all of those guys. I should do num. No, I did that backwards. Yeah. The prev of index I is equal to, is it equal to j. Yeah, this doesn't work. Actually, that does make sense. Here's a solution of 4. 3 maps to index 2, 3 maps to index 1, 1 maps to index 0. There you go. Yeah, here I could probably do max num as well, and things would be just fine. To do max num might work as well here. And here just do something like String best index equals. Let's just do that. Oh boy. Why? We might as well do greater equal. I guess either solution would have worked, right? So, yeah, either solution works, so it's actually kind of fine. We don't need to do a greater equal here. We'll actually make things a little faster by not doing so. Then we'll do, yeah, for the president, yeah, let's equal this. Turn res. Maybe I can get away with a greater equal. Might as well populate more values. Where's that? That's so annoying. It just doesn't have one yet. Prev dot get best index. Come on. Well, this is actually kind of nice. And it doesn't work. It's 1. 0, 1. Up to 0. Is not none. It's because it thinks 0 is false, right? Yeah, there we go. Okay, let's submit. And there we go. Bada bing, bada boom. Completion streak 264 days. Consistency is key. See ya tomorrow. Okay, sweet. Now let's remove all our prints and make them hashtag prints. Okay, there we go. That might make things a little faster. Nice. This might make things a little faster too. Yeah, here we don't really like the nums. Alright, let's see if this affects anything. Yeah, we don't get to make that assert. But now this should still work, right? As I continue. Oh wait, this might actually be necessary in order to make this problem a DAG. Oh no, this is just fine. Yeah, okay, it does work. It's just, yeah, it's just a little more efficient with the sorting, so you only look at the numbers that are smaller than you. Makes perfect sense. Makes perfect sense. Makes perfect sense. You might as well invest in login time initially. There we go. Okay, sweet. Right, I actually wonder, max num also works here, right? You just might as well, I guess not. Alright, I'm not even gonna bother saying why, just doing num makes sense to me anyways. Yeah, alright. Oh wow, beats 91.50%. That is beautiful, beautiful, beautiful. Here we can just say best index. No, because it's just gonna be 0 as well anyways. We could also just do this by value. No, that's fine. We can do things by indices. It's completely fine. There we go, bada bing, bada boom. Beats that many solutions. It's pretty good. Yeah. No need to worry about this too much. Yeah, 89.48%. There we go, bada bing, bada boom. So nevertheless, as always in my videos, I do a quick recap of Divisible Subset problem. So this one, really, I have to give huge kudos to, let's go see it. Yeah, Selder02, we can click on this guy's profile. Thank you very much to this comrade. Wow, only 80 LeetCode problems solved, and he was able to come up with that. That is actually kind of nutty. Well, I shouldn't say only, it's just because he did it, he was coding in 2021, right? Yeah, this is when he was a bit more active. Well, darn, man, this guy, you're pretty good. Yeah, so kudos to this no solution over here, which I upvoted. This is what I used in order to solve the problem. So I recognize that this is probably going to be a DP problem, just because it's a very obvious setup, right? You have to deal with subsets, not subarrays, and backtracking is off the chart, because here you have 1,000 for nums length, which means you can tolerate at most an n-squared solution. Doing this with backtracking would require, exponential time, which is not possible. There was another discussion comment that essentially made me realize one thing, which is like, okay, if we treat any single two indices in nums and just say like, okay, if nums of I modulo nums of j is equal to 0, or nums of j modulo nums of I is equal to 0, then essentially you can consider every index as a node and essentially put an edge between every two pair of indices if nums at index I and nums at index j, either way modulating one with the other gives you 0, right? And then essentially what you want to do is find the maximum maximal clique inside of that graph, right? Which is, it's an NP-complete problem, right? So assuming P doesn't equal NP, there's no polynomial time algorithm to solve that, let alone like, an n-squared solution in order to solve that. So one thing I realized that must be true for this problem, right, is that we must somehow leverage properties of modulo in order to solve this problem in n-squared time, right? If we can't, then this problem basically problem reduces to clique, right? Which with well, okay, there's no known way of making this polynomial time, so forcing us to come up with a polynomial time algorithm, probably not what LeetCode intended, right? And so thanks to this guy, I figured out, okay, here's how you leverage properties of the modulo, which is that essentially keep track of a maximal number, and you essentially say, okay, if something, you keep track of a maximum number, and you say, okay, if something divides by that divides into this number, then okay, let's look at all the things that divide into this number and say, okay, all of these guys divide into this, right? Because if you have everything divide into a smaller number that divides into another bigger number, then all those small numbers essentially divide into that big one, right? That's kind of the mindset, where it's like essentially kind of the way that he approached the problem, right? And so using that, then solving the rest of this problem is not as difficult, because essentially then you can realize, okay, here he tells you to sort. Sorting is only for efficiency reasons, because you want essentially from like, a certain number, you want to look over all the smaller numbers. So having the array sorted will let you do that efficiently. Otherwise, no problem just looping through all O of n numbers. It will not ameliorate the asymptotic time complexity, but it's just a little nice to have. And so here I essentially have dp with I and a maximum number. This maximum number, I essentially want, I want everything to essentially divide into this maximum number. There's at most n numbers. Well, in this case, there's exactly n unique numbers. But it doesn't matter, because here we're going to, could I do this based off index I? I probably could, right? Max num is equal to nums of I. Sub that nums of I. I'm just gonna try something here. Right, because this is n squared. Yeah. Nums is equal to self dot nums. Nums of I. I insert a memo. Nice. All right, sweet. Sorry, that's just something I'm realizing as I'm doing this problem. And yeah, okay. So it seems like a little bit slower and so on. Not too big a deal. Here we can cache things if anything. There you go. It might make us a little bit faster. All right, let's see. Not really. Yeah, we can just put this down here. Yeah. And there we go, P71.5%. Okay, yeah. Just to make it clear that, yeah, this is actually a 1D DP problem, just with O of n work inside the body. Essentially, you have an index I, and you essentially say, okay, I'm going to treat this number at index I as my maximum number, right? And that's kind of why it's going to be convenient to sort the entire array, because it's just like that way you can essentially look at numbers that are just strictly smaller than you by looking at smaller indices. It's just like convenient side effect here. Essentially, you're going to say, okay, right now, the number at index I is going to be the maximum number, because I'm only going to consider the number at index I and everything smaller. And here, considering the number at index I want to include the number at index I as part of my solution. So first of all, if I is out of bounds, if I is less than 0, return 0, right? Otherwise, we'll default to a result of 1 because we want to include index I, right? So here I'm going to get my nums. My quote-unquote max num is going to be equal to nums of index I, because here we're going to loop through every single index j up to I not inclusive. And remember, nums is sorted, so we're going to only deal with smaller numbers, so we set this to our maximum number. And then for each number, so we'll say num is equal to nums of j. If that number divides into max num, right? If max num modulo num is equal to 0, right? It can't be the other way around, right? Unless num is 0, but whatever. Plus, I don't even think that's possible, right? Because all of the numbers are, all the numbers are greater or equal to 1. So this is the only possible way that this is going to happen. Here we'll say, okay, if num divides into max num, then I want to say, okay, what are all the numbers that divide into num? Well, all the numbers that are divided into num are going to have to be numbers that are smaller than num, right? So I'm going to go from index j and downwards, right? And but self.dp of j will be all the numbers that divide into number, right? So that's kind of the trick here, right? And here I include the number at index I, because it's like, okay, num divides into the number at index I. So I'm going to include the number at index I and get all the numbers that divide into the number at index j, because all those numbers must transitively also divide into this maximum num from index I, right? That is the quote-unquote part where you leverage properties of the modulo operator, right? That is the thing that I was missing, that I could not come up with myself in this problem, that my good friend Mr. Selder02 from November 15th, 2021 was able to show us today. Yeah, this is unironically very, very clever, but that's essentially how you leverage the modulo part in order to solve this problem in an efficient time complexity. But this is honestly pretty witty stuff in terms of, like, you know, this is very smart stuff. So yeah, this is pretty clever. And then you say, okay, we want to get the, you know, the best result, so you want the one with the maximum length. So okay, if res is less than the length of this case, then that's an even better case, so set res to equal to that case. And another thing that's very smart is like, okay, in this case we're going to say, okay, the previous index to I will be j, so that way we can essentially build a solution, right? This is very similar to Dijkstra's algorithm, where it's like, you know, you use a prev dictionary or array so that you can essentially keep track of, like, you know, the shortest path at the end of the day once you've run Dijkstra's. Here is just applying the very same thing, having a prev array, so for each index you keep track of the one that comes before it, so that at the end of the day, whatever solution is optimal, you'll be able to backtrack the entire longest chain in just O of n time very nicely, right? And then just, yeah, memorize that result so that, you know, this doesn't become exponential time, right? And then return res, and there you go, bada bing, bada boom. That is how this DP function works. And then this is exactly it, right? Here we're going to essentially loop through every single possible index I, and essentially find the one that gives us the maximal length, right? So for I, num and enumerate nums, let's call DP from index I, set that to the length using the walrus operator, and if this is better than the current best length, which we initialize to negative infinity, whatever, then we'll say best length is equal to length, and best index is equal to I, right? So that way best index, we'll have best length, right, which is the longest length possible, and then we'll start off with, you know, best index, which is, like, you know, the largest index where that, you know, longest length happened from at the end, so that you can essentially backtrack from using the prev array, right? And that's exactly what we'll do once we have best index. It's like, okay, well, best index is not none, let's append the number at best index and essentially say best index will be the previous one. So, right, so self.prev.get the value at best index, or otherwise, if there is no previous index, then set it to none, so that way we'll break out of this while loop, right? And that's pretty much it. And then at the end, we just return res as we append every single number from that best index wherever that best length was, and going backtrack with the self.prev dictionary, and there we go, bada bing, bada boom. We have a reasonably efficient solution to this problem. But this was only thanks to this comment over here, because without it, I probably would have never. Well, I don't know about I probably would have, quote-unquote, never solved this problem. At least it would have taken me 5 hours. I don't think I could have done this without hands, right? Maybe it's like, you know, if I think hard enough, and it's like, okay, yeah. But it's like, that's a lot of details to get right. Where it's like, you know, as soon as I start, like, thinking in terms of this path, I'm like, no, this is too much. This is not what they would expect. So I definitely would have at least spent way too many hours. So I'm glad that I looked at the discussions. But yeah, this is actually a very nice and neat little solution trick. And yeah, but otherwise, that's pretty much it for this video. If you did find it useful, enjoyable, and any way to perform, I'd highly appreciate if you left a like or a comment. But otherwise, I'll catch you next one. So until then, ciao, ciao, my friend. Bye-bye.